Bismillah ar-Rahman ar-Rahim. This lecture is chapter 15. We will spend inshallah 2 lectures in chapter 15. This one is about the composition of matter. We will classify the matter into 2 kinds, okay, and we will see the classification of each kind of them. So the matter, we will see that it can be classified into pure substance or a mixture. And the pure substance also can be classified into chemical compounds or elements, while the mixture can be considered as homogeneous mixture or heterogeneous mixtures. First, we need to understand with what is the matter. The matter is anything that takes up a space and has a mass. It's called matter. So all the solids around you, that's matter. All the liquids that you see, matter. Gases, matter. Plasma is a matter. So anything that takes up a space, whatever the space is, small space or big space, and has a mass, it's a matter. Maybe some matter, we can see it, like liquids or solids. Sometimes we cannot see it, like some kind of gases, like the air. Air is a matter. It's around us and we cannot see it, but it takes up a space and it has a mass, so it's considered as a matter. Let's see what's the classification of matter. Matter can be classified into pure or mixture. Pure substance مادة نقية, mixture خليط أو مخلوط. What is the pure substance? It's a type of matter which has fixed components. The pure substance might be an element or a chemical compound. An element or a chemical compound. What is the element? Element is a kind of the pure substance. It's made up of the same kind of atoms. The same kind of atoms. Like what? Like iron. Iron is a pure substance because it's an element. Nickel, copper, okay, uranium, okay, lead. All of these are okay, for some elements. It might be hydrogen, like H2, oxygen, like O2, nitrogen, like N2. All of these also are single kind of atoms. Although it's a molecule, it's a chemical molecule, but it's an element. Why? Because it's single kind of atoms. Hydrogen only. Of course, we have 2 atoms of hydrogen. They are chemically combined. But as long as it's a single kind, hydrogen only, so it's an element. Oxygen is an element. Nitrogen is an element. Okay? There are like 90 natural elements on the earth. They are found naturally on the earth. Some of them are common, some of them are rare, but there are 90 natural elements. There are more than 20 elements that are made in the lab, in the nuclear reactors, in the accelerators. Okay, so they are artificial elements. We cannot find them naturally on the earth. Maybe they are found in somewhere else in the universe. But on the earth, we can make them in the lab. The other kind of the pure substance is called the chemical compound. The chemical compound, it's also a pure substance, but the atoms, it contains atoms of 2 or more elements together. Not only that, but these elements must be combined chemically. They must be chemically combined together. Not just mix them together, no. These elements must be chemically combined together. There must be chemical bonds in between. روابط كيميائية. In this case, we call it a chemical compound. Like what? Like the H2O, the CO2, like the NaCl. H2O is water. That's called water molecule. Okay? It has two kinds of atoms. It has the atoms of hydrogen and the atoms of oxygen. And these atoms are not mixed. No, they are chemically combined. They have a chemical bond. CO2, carbon and oxygen, chemical bond. NaCl, sodium and chlorine. There is a chemical bond in between. So all of them are chemical compounds. Okay? So the element or the chemical compound, they are pure substances. Pure substances. There are two important notes on the chemical compounds. The properties of the chemical compound are not the same as the properties of its elements. The properties of the chemical compound are not the same as the properties of the elements. Like if I have CO2, CO2 has carbon and oxygen. Oxygen, if it is in natural state, it's called O2. Okay, it's an element and it's a gas. It has its own properties. We can find it in the atmosphere. Carbon, in its natural state, is a solid, like graphite. Okay, the graphite is the carbon in its solid. Of course, there are other forms of carbon, but the common solid one is the graphite. Okay, if it is a single element. So they have different properties, but when they combine together to form the CO2, CO2 has new properties, خصائص جديدة, new properties, new melting point, new boiling point, new physical properties, new chemical properties. Okay, so it has no relation to the properties of carbon or the properties of oxygen. What else? The elements that make up the compound cannot be separated by physical methods. Like you cannot separate the carbon from oxygen here with the physical method. Like if you put them on the stove, okay, you cannot separate them. But to separate them, you need a chemical method. You will need a chemical method to separate the compound. Okay? Although actually, to be honest, you might give heat if you heat up something, if you heat up the compound, but to very, very high temperature. Okay, which is not common in the daily life. Sometimes you can decompose it. You can decompose the chemical compound using the heat, for example. And the heat, usually it's considered as a physical method. Okay, but if you heat it up to very, very high temperatures, okay, if you give it enough amount of energy, you can separate actually some compounds. Okay, but in general, we consider that the chemical compound cannot be separated by physical methods. It needs chemical methods. That's in general. So the pure substance, which is the first kind of the classification, can be an element or a chemical compound. The element, it might be atomic element, like neon, for example, like iron, like copper. All of these are atomic. Or it might be molecular, like O2, like H2, like N2. Okay, that's called molecular because the two atoms are combined together, but it's a single kind of atoms. Only oxygen, or only hydrogen, or only nitrogen. So it's also element. The chemical compound is two or more kinds of atoms, but they are chemically combined together. They have chemical bonds. And we will study, inshallah, in the next chapter that the chemical bonds in general, they are classified into molecular bond or ionic bond. These are the most common. Molecular bond or ionic bond. Okay, both form compounds. Like H2O, like CO2, that's molecular bond. Or like in case of salts in general, that's ionic compound. We will study that in next chapter, inshallah. So if you don't want to know it from today, we will know it later, inshallah. Okay, so these are chemical compounds. The second kind, we said there is a pure substance. That was the first kind. The second kind is called the mixture. Mixture الخليط أو المخلوط. It's composed of two or more substances. Two or more substances. But they are not combined chemically. They are not combined chemically. There is no chemical bond between these substances. Okay? It's a physical mixture. Physical mixture. And they can be separated by physical methods. In this case, we call it mixture. Like, for example, the air. الهواء. Air is composed of what, guys? Can you tell me? Oxygen. Nitrogen. Carbon dioxide. Okay. Sometimes there is water vapor. Okay. Some argon and maybe some other gases. Okay. Here, these elements and these compounds, they are not chemically bonded or they are not chemically combined together. No, they are mixed physically. They are mixed physically. So we can extract the oxygen, we can extract the nitrogen, we can extract the CO2 or the water vapor or the other parts of the gases, okay, because they are not mixed physically. Okay, so that's a mixture. This is a mixture. Air is a mixture. There are two kinds of mixtures. What are they? We have the homogeneous mixture. The homogeneous mixture, المتجانس. And the heterogeneous mixture, which is the opposite. So we have homogeneous and heterogeneous. متجانس غير متجانس. Let's start with the homogeneous. The homogeneous is a mixture. Homogeneous mixture is a kind of matter which is under the classification of mixtures. And here the different substances or the different components of the mixture cannot be distinguished, cannot be identified. لا تستطيع تمييزها. You cannot identify them from each other as they are constantly and uniformly mixed throughout. They are uniformly mixed. So you cannot identify the substances. Like what? Like salt in water. If you get a cup of water and you have a spoon of salt, the table salt, and put the salt in water and stir until the salt disappears or until the salt is dissolved in the water. After that, if you look inside the water, can you tell where is the salt? You cannot, because the salt particles enter through the intermolecular spaces of the water. It goes inside or in between the molecules of water. You cannot see it by your eyes, even by the microscope. You cannot see it. Okay? So, in this case, we call it a homogeneous mixture. If you leave it for a day or 2 days or a year, it will stay a solution. The salt is completely dissolved inside the water and it will stay as it is forever. As long as you don't affect on them by a heat or something, they will stay as a homogeneous mixture forever. The homogeneous mixture might be a solid or a liquid or a gas. A solid or a liquid or a gas. Liquid, in case of a liquid, we call it solution. محلول. If it is a liquid, we call it solution. If it is a solid, we call it alloy. سبيكة. So the homogeneous mixture. If it is a liquid, we call it solution. If it is a solid, we call it alloy. And gas is like the air, by the way. The gas, as we said, it's like the air. Air is a good example for the homogeneous mixture as a gas. In case of liquid, okay, it's like this solution, the salt in water. In this case, we add some kind of salt, and there are many kinds of salts, with water. The salt here is called the solute, and the water is called the solvent. مذاب ومذيب. So you put the solute in the solvent and you stir it by a spoon, or you can heat it up until the solute or the salt here is completely dissolved in the water. In this case, we call it a solution. And you will not be able to see the particles of the salt. You cannot distinguish the water from the salt. Okay, that's called solution. Like the salt in water, like vinegar. Vinegar also is acetic acid. Acetic acid dissolved inside water. If you go and buy vinegar, the white vinegar, okay, it says like this is acetic acid, I think like 5% or 6% acetic acid. So what's the rest? The rest is water. It's dissolved in water. Okay, so that's also a solution. So vinegar is considered as a solution. The alcohol, the medical alcohol, الكحول الطبي, the medical alcohol is some kind of alcohol. Usually it's 70% dissolved with water. Yeah, there are different kinds. Okay, usually isopropylene or something like that. I don't know if they use ethylene or not, but they use different kinds of alcohol at percentage 70% mixed with water. So that's also a solution. You cannot say this part is water and this part is alcohol. You cannot say that because they are mixed completely and uniformly throughout. It might be also a solid. The homogeneous mixture might be a solid, and in this case we call it an alloy, like brass or steel. Brass and steel are very good examples for the alloys. Alloy means sabika. Or the gold that we buy from the stores, okay, like gold 21 or gold 18 or gold 14 or 10. That's also an alloy. It's not a pure gold. It's gold usually mixed with other elements like copper, like nickel, like zinc maybe. I'm not sure about the material. Okay, platinum. Okay, so they mix other elements with the gold. So it's called an alloy also. Okay, the pure gold is the 24. The gold 24 is pure gold. Okay, so this is a single element. That's a pure substance. Gold 24 is considered as a pure substance. Of course, there is nothing like pure 100%, but it may be 99.99% pure. Okay, but gold 21 or gold 18 or other than that, that's called an alloy, and it's a homogeneous mixture because it's an alloy. Okay, guys? So, for example, the brass. Brass is an alloy between copper and zinc. Usually, in many cases, 60% of copper to 40% of zinc. Of course, they change it according to why they need it. but in many cases it's around these percentages. 60% of copper to 40% of zinc. They melt it down, they heat it up until they melt down. Then they mix both together. So they put the zinc on the copper and they melt them down until they become completely solution. They become a liquid solution. And then they pour it in some molds and they leave it until they cool down and become solid. When they become solid, we call it alloy. Alloy. And you will study this, the alloys maybe in the metallurgy, or if you go to the Department of Mechanical Engineering or other departments of other departments, maybe physics or something like that, you will study how to make the alloys. So this is a short video of how to make the alloy. That's these are some scraps of copper. They put it in a furnace, so they heat it up. And then we have some bars of zinc, that's zinc. He will add the zinc to the copper and he heats all of them together until they become a liquid. As you see here, he will leave them until they start to melt down here. Of course, the zinc melts down faster because its melting point is much lower than the copper. Okay, but he will leave them until the copper also, it starts to melt down also. So at the end, and at the end here, as you see here, it becomes liquid. All of them, they become a solution. They are mixed uniformly together. So that's not copper and that's not zinc. No, they are mixed together. That's a solution now. They will pour it. Now they will pour it in a mold. So they cast it. Very, very high temperature. Very, very high temperature. They must be aware and they must be cautious. They will start pouring them. When they finish that, they will leave them in the molds for maybe a few hours until they cool down. Okay, so at the end, it becomes an alloy. So this is not copper or zinc. That's an alloy of copper and zinc. Okay, so that's a homogeneous mixture. Okay, guys, do you have any question in this one? Go ahead. Steel what? Yeah. Steel also, it has a similar process. Steel is a mixture between iron, carbon. They use also sometimes nickel or manganese. It depends on the kind of the steel. Okay, there are different kinds of steel. Okay, so they mix them also together. They have to melt them down, similar to what they did with the copper and the zinc. Okay, then they mix them and they put them in molds, or they have other techniques in the industry. Okay, but it's the same method to make the steel. Yes. The other kind of mixture is the heterogeneous mixture. The heterogeneous mixture. In the heterogeneous mixture, the components or the substances of the mixture remain distinct. They are still, you will be able to distinguish the substances from each other. Like if you have a plate of fruit salad, you have some parts of fruit together. If I ask you where is the orange, you will tell me this part or this one and this one. Where is the banana, this one and this one? You will be able to distinguish the components of the fruit salad. If you mix, for example, some sand particles with some salt, especially if the salt has a certain color, like a blue kind of salts or something, okay, you will be able to distinguish the particles of the sand from the particles of the salt. So as long as the different materials remain distinct or remain distinguished, so that's called the heterogeneous mixture. And it has two kinds, the colloids and the suspensions. الغرويات, the colloids, and المعلقات أو المعلق, because المعلقات is something else. The suspensions. Okay. What is a colloid? Colloid is a heterogeneous mixture in which particles never settle down. The particles, they still hang inside the liquid. Okay? Like what? Like, for example, the milk. If you look at the milk under the microscope, you will find the particles of the fat, which gives the milk the white color. The particles of the fat, they hang in the water. So they do not settle down, لا تترسب. So as long as it stays in its place, so that's called a colloid. Blood also is considered as a colloid. Blood contains the red cells, the white cells, the platelets, and the plasma. And they are mixed together, but you can distinguish them under the microscope. You can see the red cells, you can see the white cells, okay? So it's not a solution. Okay, and they don't settle down. If you put them in a tube, okay, they don't, like the white cells and the red cells under the normal conditions, they don't settle down. Okay? To separate them, you need a physical method, like the centrifugal devices, أجهزة الطرد المركزي. Okay, using these methods, these physical methods, you can separate the fat from the water, or you can separate the blood cells, like the white cells, from the red cells, from the platelets, from the water, or from the other components, which is the plasma. Okay, you can separate them, but you need a physical method. But if you leave them as without any effect from outside, they will stay where they are. They still hang inside the liquid. So they are colloids. How to differentiate between the solution and the colloid? There is a method, or there is a test called Tyndale Effect. In the Tyndale Effect, have a source of light, like a beam of laser or whatever source of light. If the light beam goes through the substance without scattering, بدون تبعثر, without scattering, so that's a solution. If the light beam goes through the substance without scattering, so we consider it solution. But if the light beam scatters when it goes through the substance, if it scatters, and you can see the scattering as you see it here in this picture, so it's a colloid. So why the light scatters from the colloid? Because the particles of the colloid are big enough, like the fat of the milk. It's big enough, so when the light beam or the photons hit these particles, they scatter. The photons scatter in all directions. They scatter randomly in all directions, so you will be able to see this scattering by your eyes. This test is called the Tyndale Effect. Tyndale Effect is the scattering of light beam as it passes through what? The colloids. when it passes through the colloids, it scatters. So that's called Tyndale Effect. A good example for that, when you turn on the high beam light, the high beam of your car. Call it the highlight. Okay? So in the early morning, when there is a fog, ضباب, if you turn on the highlights, you will not be able to see anything in the road. Why? Because the fog scatters the light in all directions. So you will not be able to see the road. That's why if there is a fog, it's recommended to use the fog lights. The fog lights are some lights toward the ground. It doesn't go toward the fog itself. It tries to go toward the ground. Okay? This will lower the scattering, so you will be able to see the road. Fog is a good example of a colloid. Fog is a colloid. What is the fog? Fog is the particles of water, medium particles of water, that hang in the air in the early morning. Its height is like 5 meters, 6 meters, okay, above the ground. Usually you will find it in the cold weather, because the cold weather allows the water vapor to partially condense. It will partially condense to form medium-sized particles. And the medium-sized particle, it will hang in the air, so that's considered as a colloid. When the sun rises, it will heat up the area. So when the temperature increases, the particles changes into water vapor again, and it will move to the upper parts of the atmosphere, and it will disappear. So the fog is a colloid. The last kind of the heterogeneous mixture is the suspension. The suspension is also a heterogeneous mixture like the colloid, but the particles of the suspension is bigger. The particle is bigger and heavier. Because it's bigger and heavier, it can precipitate. It can settle down in the liquid. So if you have water and you try to mix it with sand, water with sand, try to mix them. After you finish mixing them up, you will find directly that the sand settles down to the bottom, because the particles of the sand are big enough and they are heavy enough, so they settle down to the bottom of the container. So in this case, water, the mixture of water with sand is called a suspension. Like the river water, it's also a suspension. You will find the particles of sand, it moves down and it settles down to the bottom of the cup or the beaker. So that's called suspension. So what's the difference between solution, colloid, and suspension? All of them are mixtures. So all of them are mixture, but solution is a homogeneous mixture, while the colloid and suspension are heterogeneous mixture. In case of solution, the particles are dissolved completely in the liquid, or the particles of the substances, they are completely dissolved in each other. Okay? You will not be able to distinguish them, like the salt in water. So the particles here are very small, and you cannot see them or you cannot distinguish them. In the colloid, the particle size is medium, like in case of the milk. And they are not heavy. Their density is medium also. Medium density. So they still hang inside the liquid, like the fat of the milk. The fat particles of the milk, they don't settle down. Or like the fog, the particles of the water, they do not settle down. The suspension, the particles are big enough and they are heavy enough. The density of these particles are high enough so they can settle down to the bottom of the container. So that's the main difference between the solution, the colloid, and the suspension. So here in this question, a pure substance that will be decomposed by a chemical method. What is it? Pure substance which cannot be decomposed. It cannot be separated by chemical method. What do you think? Is it the compound or colloid or element or solution? Of course, not a colloid. It's not a solution because these are mixtures. Is it a compound or an element? It's an element. Why? Because the compound can be separated. It can be separated or decomposed by chemical methods. While the element cannot be separated. If you have hydrogen, you want to separate it into what? You will make it helium or you will make it lithium. Okay, you will make it another kind of elements. You cannot. By using chemical method, you cannot. But using maybe nuclear methods, you can. If you use a nuclear method, you can change an element to another element using nuclear means, but not chemical means. Yes. You can separate them chemically also. Okay? You can separate the mixture chemically. But usually it's easier. Okay? And it's available to separate the mixture with a physical method. Okay? The scattering of light beam as it passes through blank is called Tyndale Effect. Through the colloid. Why? Why the colloid scatters light? Yeah, the particle size are medium, so it's able to scatter the photons in every direction. That's called Tyndale Effect. Okay, guys, we are done. If you have a question, please go ahead.